So solution of an inequality is any number that makes the inequality true. So there are 4 different inequality symbols. There's a less than symbol, which looks like that. Less than. So as we read from left to right, if it's pointing towards the variable, we'll do some examples in a minute here. We'll do several examples. So let's just get the words and the symbols. We're not going to worry about the graph just yet. But less than. Then we have greater than, looks like that. Remember, as we go from left to right, so if it's opening up towards the variable, it's greater than. Then we have the less than or equal to symbol, which has a line underneath it. And then the greater than or equal to symbol. So those are the 4 inequality symbols. Now let's, I know, you've seen this before, I know. Just as a review though, I'd like to do one example of each on here and show what the graph looks like. So if I had x is less than 2, we would have an open circle at 2. It's open because it does not include 2. And I would shade on the number line to the left. Some students will do a little arrow up and over. A different one than you? Put an open circle at 2. Open circle at 2. And then shade to the left. You have to fill in. I'm just making this up. X is less than 2. What if I wanted to do x is greater than 2? Circle, and it would go shade to the right. So one example of a number greater than 2 would be 2.1, 3, 4. 8,372,000. Yeah. And then x is less than or equal to 2. The only difference here from the first one is that it would be filled in, circle, and then I would shade to the left. And then x greater than or equal to 2 would be filled in, circle, and shaded to the right. Some students will do this, and then you don't have to shade over that darkened line already. That's fine. Make sure you get the closed circle versus open circle. So those are graphs of the 4 different inequalities. All right, let's mix it up here a little bit. This is writing inequalities from words. So it says, what inequality represents the verbal expression? So this says all real numbers x. So start by writing down an x. Less than or equal to -7. So the less than or equal to symbol would be that. Less than or equal to -7. All real numbers m less than 100. So it would be m less than 100. And 6 less than a number k, this less than means subtract. And this greater than is the symbol. So it looks like this. It's k minus 6 is greater than 13. So 6 less than a number. We're not going to write 2 inequalities here, or a compound inequality. We're just saying 6 less than a number k. So in other words, subtract 6 from k. Is greater than 13. What's up?
So these equations that are variables equal.
Yep.
So
it is. On this one, if you were to solve it, the variable could be anything that would make this bigger than 13. We're going to learn how to solve that. Yep. Anything bigger than 19 would work. We haven't really talked about how to solve that, but we're going to parallel what we did last chapter. We're going to do 1-steppers, 2-steppers, and then what are called compound inequalities. and then absolute value inequalities. So. And then there'll be more skills to go with that, and I'll reintroduce the skill. Like we're going to go back, we've done 3 out of 4 tries on the first skill. We've done 2 out of 3 tries on the second skill. We're going to introduce the next skill, and you'll do, the 4th try of one, the 3rd try of the other, and the 1st of the other. So bring those back in. So now you try. It says all real numbers p greater than or equal to 1.5. So go ahead and see if you can write it. And it should look like that. This one's like the 3rd example. They're the sum of x and 7. The and means plus. So x plus 7 is less than -3. So there it is. X plus 7 is less than -3. So you'll be asked to take some words, translate them into inequalities. We actually do these all the time. We don't necessarily write down the inequality, but we think in terms of, you can't have any more than this many people in the room, or you can't have any more than this many on the team. Those are all inequalities. So we use them all the time. We just don't necessarily write them in algebra form here. So identifying solutions by evaluating. Is the number below a solution of 2x plus 1 greater than -3? We're not going to solve it. That would be the more efficient way to do this. We would tell you which ones of these would work and which ones would not. But at this point, we're just going to plug in the value. So, for example, 2 times -3 plus 1. The question is, I'll put a question mark over that, is that greater than -3? So 2 times -3 is -6 plus 1. Is that greater than -3?
No.
-5 is not greater than -3. If you want to, you can put a little slash through it. So the answer is no. It is not a solution because -5 is not bigger than -3. If you think about the number line, here's 0, here's -3. Where is -5 located? A little bit farther to the left of -3, right? The next one here, 2 times 5 plus 1, is that greater than -3? Maybe 10 plus 1 is 11. Is that greater than -3? That is a yes. So just write yes here. And then -1.
It's only greater than, not greater than.
We're just looking for greater than. So -2 plus 1, is that greater than -3? -1 greater than -3. Think about our number line here. Is -1 to the right of -3 here? Yep. Be right about here. So this is a yes. All right, quickly just try the one on the next one down here. Tell me which of those, if any, are a solution to that inequality, if you could. All right, so yeah, the first one is a no, definitely not. This one, because it ends up being 6 less than or equal to 6, that is a true statement. So this is a yes. In problem 2, how is the solution of the related equation 2x plus 1 equal to -3 related to the solutions of the inequality 2x plus 1 is greater than -3? Well, it's related in that you can just solve it to get the entire solution set. What I mean by a solution set is that there's a whole bunch of numbers, actually an infinite number of numbers at work. And you can find out what all of them are in terms of the inequality here. Here's what it looks like. You can subtract 1 from each side. So 2x is greater than -4. Then you can divide by 2. And x is greater than -2. And so what this tells us is that anything bigger than -2 larger than or greater than -2 will work. And then you don't have to go through and test each and every number like we did up here. Sorry, I'll go up here. So anything bigger than -2 will work. So is -3 bigger than -2? No, it's actually less than it, so no, it doesn't work. Is 5 bigger than negative 2? Yes. Is negative 1 bigger than negative 2? Yeah. So you don't have to test each and every number. You could just solve the inequality like it's an equation, and it gives you the whole solution set and graph it. So what we do is, instead of listing it in like what's called interval notation in Algebra 1, we just draw a picture of all the numbers that work, that make the inequality true. That's what your number line shading is. It's showing all the infinite number of values that work. And later on, you'll learn how to write that in what's called interval notation. And then you don't need the picture. So x is less than negative 3. We just graph this thing. Where does the circle go? It goes to negative 3. Is it open or closed?
Open.
Open. And then, last year we would talk about, okay, well, as long as the variable is on the left, this thing points in the direction of where you're supposed to shade. As long as the variable is on the left, right? So this says x is less than, this is a less than, in words it's saying less than, negative 3. So less than negative 3 would go that way. Now this one, notice how the variable is not on the left. Could I put it on the left? Could I rewrite this in such a way that if I go x, flip it, is less than or equal to 2. So this says less than or equal to 2. So I put a closed circle at 2, and then based on this one right here, I will shade to the left of 2. So be careful with that rule. You got to make sure that the variable is on the left if you're going to shade in the direction in which the inequality is pointing to go. Got it? And it's easy to put it on the left. Just when you flip it, make sure that it's pointing the same way it was. See how it's pointing at x? When I flip it around, it's still pointing at x. You try the next two here, or 3. There it is for those 3. On the third one, changed it around so the letter was on the left, and I read it from left to right. N is greater than or equal to 3. Notice the open circles on the first 2, closed circle on the last. What about going the other direction? This is what we do in math. It's like, here's the inequality, you graph it. Now here's the graph, you write the inequality. What's this say here? X is, it's equal to, yep, so put a line underneath, and also greater. So it's greater than or equal to negative 1 for that one. That's this one up here. The next one here, this says x is less than 4. So we're starting at 4. There's no line underneath it because we're not including 4. You could get right up against 4. You could be at 3.9999999. But you can't be at 4. All right. What about here? This is x is greater than negative 2. Why don't you try each of the you try ones? I'll follow right behind you. X is less than negative 3, and x is greater than or equal to 0. That's it. There it is. Here's some, I attempt at some real world inequalities, although the speeding limit one, I don't know about that. Have you seen a speed limit sign that looks like this? Is it rectangular and yellow? Where? What's that?
So that really slow.
I know, but even, okay. Yeah, I guess you're right. If like a private neighborhood or something, no dust.
Oh, the way, the shape.
No shape, yeah, it's kind of weird. But anyways, it says, write an inequality that describes the situation. So this says trail ride starting at $19.99. So what's the minimum you would pay? $19.99, and then it's going to go up from there. Could it be $19.99? Yes. Could it be more than that? Yeah, it probably will be. Usually an advertisement it says starting at. If you go online, you're ordering something starting at. So I recently ordered a muffler or whatever for my dirt bike. like so starting at this price, it's like, well, it depends on what model and make you have. They all go up from there. So if you had a mini bike, it was probably that starting price, a little 85 or something. That's what it is. But if you know, as it goes up from there. So trail rides starting at 1990. So that's the one where they hold on in the middle. So you stay in the crowd, you never leave the crowd, you just go in circles. But if you want to go out into the wilderness, it goes up significantly. 8 miles per hour, I think what they mean here is X is less than or equal to 8 miles per hour, because of course you can be going this speed. So that's why it's less than or equal to, you just can't go over. For the speed limit question, can the speed be all real numbers less than or equal to your solution? Well, what kind of speeds could you be going? Can you go negative speeds? That's really what this is asking, right? Is it really all real numbers less than or equal to 8? Well, not quite. Really,
Backwards.
it means you can go.
Negative speed because you're not going forward to be positive.
That's true. In physics, it is negative velocity, yeah. But speed is actually the absolute value of velocity. So yes, velocity can be negative. It means you're going in the opposite direction. But speed cannot. Speed is the absolute value by definition. But it means you can go anywhere between 0 and 8 miles per hour. And here's the thing. There's a way we can actually write this. It looks like this. You stick X in here. Here's X. It's in between. It's greater than 0 and less than or equal to 8. So what we really mean is this inequality. This is called a compound inequality. Notice I have strictly greater than 0 on the left. Because if I'm going 0, I'm not even moving. So I guess you could be going 0 miles per hour. It's kind of up to debate whether there should be a line. But the speed limit would be anything between 0 and 8, including 8. I don't know. Aren't you parked if you're going 0? And anyway.
How are you
How's
going?
that speed? That's what I'm saying. I'm saying it's not.
Are you saying
That's why I have
0 miles
greater
per hour
than.
if you're not going anywhere.
Yeah, that's what I'm saying. I'm saying the same thing you are with this inequality. So this inequality, it says that the speed has to be between 0 and 8, but 0 is strictly greater than 0. So you got to be registering on the speedometer. All right. Section summary here.